Now that we've seen what different types of systems look like based on their graph or their equation, we're going to find out how to solve them. The first way we're going to learn how to solve systems is by graphing. Now you may be wondering why there's no graph on our paper. It's because we will be using a graphing calculator to find our solutions. So here I have Desmos pulled up and I already have the first two equations typed in. I'm going to turn them on and Desmos will graph them for us one at a time. Our first equation was y equals 3x plus 5, and our second equation was y equals negative x minus 3. We're going to hide this so we can see the graph a little bit better. And we can see where they intersect right here. We can try reading it off the graph, but if you click on it, Desmos will give you the point of intersection. That is the solution for our system, -2, -1. Here's what we're going to do with that solution. We're going to check to see if it's true in both equations. -1 was our y value. I'm checking the first equation first, and -2 was our x value. Using order of operations on the right-hand side, 3 times -2 is -6, and -6 plus 5 is -1. So it checks out for our first equation. Let's see what happens for that second equation, substituting -1 for y. Now be really careful on this one. There is a negative sign in front of the x that we cannot drop, and our x value is -2. We can't drop that negative sign either. Keep both of those negative signs. Order of operations on the right, the opposite of -2 is 2, and 2 minus 3 is -1. So it checks out for that as well. Here's our next system. Again, I've got these ready to go on Desmos. We'll just pull those up. Turning on these lines one at a time. There's our first equation, 2y equals -3x minus 6, and our second equation. Notice what happened. That orange line went on top of the green line. These two lines are exactly the same. They have many solutions. Our last example, setting up a system from word problems. When we identify the variables, it's helpful to look at the question. It can give us a hint as to what our variables are going to be. How long, which means we don't know time. Looking through this word problem, we're learning that they're earning interest per week. So I'm going to say W is our time in weeks. And the other part of the question is for the accounts to have the same amount. So we're talking about the money in the accounts. All right, going back and seeing how much money. Johnny has $40 invested and it earns $2.50 of interest per week. So the money that Johnny has is $40 plus that interest of $2.50 per week. Sylvia invested $20, but her account pays $3 in interest per week. So Sylvia's money is $20 plus $3 of interest per week. Let's take a look at Desmos to get these graphed and solved. So I have our equations entered on Desmos. We'll turn them on one at a time. Here's Johnny's information and Sylvia's equation. We can't quite see where they intersect, so we'll change the scale on this one. Now that we have the lines zoomed in a little bit, let's see if we can figure out where they intersect. And we are getting 40, 140. Our question was how long? Well, we made weeks our independent variable, our input, so that would be the x-coordinate of the graph. So it looks like it will take 40 weeks for the money in the account to be the same, and that they would each have $140. Let's check to see if this solution is accurate. In Johnny's equation, we're substituting $140 for the amount of money he has, and we're substituting 40 for the number of weeks that he's leaving his money in this account. Simplifying on the right-hand side, 250 times 40 gives us $100, and of course 40 plus 100 is $140. So it checks out. Johnny will have $140 in his account after 40 weeks. And let's see if it checks out for Sylvia's account. Will she have $140 after investing $20 at $3 a week for 40 weeks? does 140 equal 20 plus 3 times 40 is 120. Sylvia will have $140 after 40 weeks as well. You have two you-try questions. Try playing around with Desmos, see if you can find the solution for number 1, and practice setting up the system of equations for question 2.